Greetings folks, welcome to a chat from the engineering desk, a new one and the first one for 2020. Our first video for the year is going to be a series of videos which is going to be all about an optics discovery kit which is from the Optical Society of America in collaboration with Edmund Optics. Contains about a dozen experiments. We're going to be looking through it. I'm going to talk you through what the kit's all about in this first video, and we're going to go through the first experiment together. So as you can see in this kit, it comes with a selection of cards which we're going to be reviewing. I'm going to set those aside for now, and then we're going to have a look at the contents of the box. There's a couple of goodies inside there. Over there we've got some fibre optic cable. We've got a packet of 3 lenses. We've got a lens. Got some holograms. Over there we've got Fresnel lens. We've got polarizers. We've also got some further items which will be covered in later experiments, and that is the contents of this kit that we're going to be looking at today. So over here we've got the first card. This is what it looks like on the front and the back, and I'm going to be talking about what they give us to do in this first experiment. Alright, so let's have a look at this first card over here. So what we got is we're going to have a light source, which in this case is going to be a card, which I'm going to place over a LED, which is a chip-on backplane array. What I've done is I've printed out some graphics on the paper. I've cut them out, and I'm going to hold them over the light source, and then over here we're going to have our lens set up. I'm just going to use a clothes peg to hold it up, and then a sheet of paper tacked against the wall is going to be our target. That's going to be our first experiment. There's 2 lenses at 2 different focal lengths that they want us to use and demonstrate how it works. Now what I've done is I've printed one with the lettering the normal way around, and I printed another one with the lettering upside down, and you'll be able to see on the card where I've got the lettering the wrong way around. On the back it inverts it, and you're able to read my name on the card when it's projected on the back. Right, so what I'm going to do over here, I'm going to take one of those little cards that are printed out and hold it over our chip on backplane LED array, and when I turn up the current on the power supply you can see the LEDs light up. So grabbing a clothes peg, and take one of the lenses and put it up on my little stand there that I've got for my experiment. Get it set up, and then take my light source and my card and power that up. It's swamping out the camera a bit. And now as we bring it closer, one can see it projecting the image onto the back. Now I will in a moment show you another shot where the camera is up close and you can actually see what the image looks like on the target. So turn that off again. I'm just running it off a power supply, and I'm controlling the current to the LEDs. Now there's the other card which is printed normally, and when I just shine that through the lens, it comes out inverted on the target, which you'll be able to see on the close-up. There we go. I've got that target about 9 centimeters away from the lens, and then the LED is about 9 centimeters on the other side, so our focal length in that case is about 9 centimeters. Now I'm going to take the bigger lens and swap that out for the short focal length to the longer one, and let's see what happens here. This is going to be quite interesting, because you'll notice that I have to move quite far back to get the thing to focus. Let's get our paper onto our LED, get it lit up, and let's see if we can get it focused. Got it all nice and bright there. Let's see what happens. I don't want to focus. Not at all. Looks like we need to move our lens back a bit. Let's grab our lens and move it back a little bit. Yeah, that should do. Let's try that. Yeah, there we go. It's focusing, and we're able to see the writing and our LED backplane nicely on the target at the back. So there we can see that lens has got a much longer focal length. That's the difference between the lenses clearly demonstrated there. Right, so as you can see here, I'm bringing it in, and you'll be able to see the image appear. Now as you can see, the writing's the right way up, but that speech bubble is inverted. So there I'm showing the card which has been printed upside down. Right, and next up over here is the long focal length, which is being demonstrated here, where you can see the image from far away, so you can clearly see the LEDs as well as the text and the image on the paper which has been held over it. So that's the long focal length lens. Right, so wrapping up, this is the lenses. There's a shorter focal length lens that I used to demonstrate the short focal length. There's a long focal length lens which we had to put a bit further back to get the image to project. And there's our cards which I used as images to project on the target. And you can see on the one the writing's the right way up, and the one's the writing's inverted. And then when projected, the speech bubbles were upside down, and in the one case my name was upside down, and in the other case it was not, and one was able to read it. So that is how it works with lenses. There's the LED light source that I used. It's an aluminium backplane with some LED chips on it. It comes from a solar floodlight that failed, and I harvested these parts out of it, and it's very useful for these experiments. There's my measuring tape that I used to measure the focal length and see where my lens was placed on it. And I just improvised, used paper, boxes, clothes pegs, some tack, set the thing up on a bench, and you can get going with this experiment, find out how things work and move a few things. It's very nice. This is great. Thank you for joining me with this video as we got started with the first experiment. Got to play with some lenses and had a look at what happens with the different focal lengths, and we got to see some results. Thanks for watching. We'll see you next time. Cheers.